Hello, welcome back. This is a video from Math 8, and we're going to be, this is Unit 8, Section 5, and we're going to be talking about similar triangles. And the first thing I want to tell you about similar triangles, because this is something that will pop up for years and years and years throughout your math career, is that similar triangles are the same shape, but they're just different size, okay? And we've talked about this. But we've talked about similarity and we've talked about, scale factors and stuff like that. But we're going to talk specifically about what makes these types of shapes, specifically triangles. And so what we want to do today is identify the proportionality of side lengths to determine triangle similarity, write similarity statements, and analyze and apply the third angle theorem and angle-angle criterion to similar triangles. So the first thing is characteristics of similar triangles. Corresponding angles. Corresponding angles of similar triangles are congruent. So corresponding angles of similar triangles are congruent. Okay? And so from there, let's look at these triangles. Okay? And what we know is that angle N is congruent to angle S. That angle M is congruent to angle R. And that angle O is congruent to angle T, okay? So because of those statements, and let's write those out, all right? That angle N is congruent to angle S. Angle M is congruent to angle R, and that angle O is congruent to angle T. So because of all those statements, we can then conclude that triangle NMO is similar to triangle SRT, okay? And so from that, we can write those statements, and this is a similarity statement saying that one triangle is similar to the next, okay? And so that's what we've got. So if all of the angles of one triangle are congruent to all the angles of another triangle, then we conclude that the triangles are similar, that they're the same shape but different size. Okay, so let's also talk about corresponding sides. Now, corresponding sides are proportional. So are proportional, which means that the ratio of their sides are going to be equal. Okay, so we're going to write some fractions and do that. So corresponding sides are sides that have the same relative position in two triangles. And let's list out what we can do here, all right? So what I want to do is look at my small triangle. We're going to go small to big, okay? And so we'll call this, let's find the smallest side of RT, of my small triangle, which is length RT. And if I find the smallest length of my bigger triangle, that's going to be length MO, okay? And so RT and MO correspond, okay? And that's what that means. Corresponding sides are in the same relative position. My medium length on this small triangle is length ST, okay? And correspond that to the other one is going to be NO. Those correspond, all right? And so then the last one is the large side of my small triangle, which is a length of 4. And then the large side of my big triangle is 12, all right? So all those sides correspond. Now the question is what can we conclude about this? If I take each of these and multiply 4 by 3, I'm going to get 12. If I multiply 3 by 3, I'm going to get 9. If I multiply 2 by 3, I'm going to get 6. So my scale factor, okay, is 3. All right, and if all the sides have that same ratio, all right, and if we can do this, we can go big to small. If we do 12 divided by 4, that's going to be equivalent to doing 9 over 3, which is equivalent to 6 divided by 2, because all of those ratios, all of those fractions are going to give you the same thing, which is 3, and that's your scale factor, okay? And so therefore, if all sides are proportional, okay, then we can say that they're congruent or similar. So I would say that triangle SRT is similar to triangle NMO, all right? And that's what we do, okay? Now let's take a look at similar versus non-similar triangles. So over here, we have these triangles are similar, okay? And here's why. Because over here, if I wanted to take a look at, say, this triangle here, what I know is that angle E plus angle D plus angle F, if I add all those up, I'm going to get a total of 180 degrees, okay? And angle E is 55.8. Angle D is 81.2. The question is, what's angle F, okay? And I know that they're going to all add up to 180 degrees, but let's figure out what angle F is, and then let's look over at this triangle to see if we notice anything, okay? So if I do 55.8 plus 81.2, and let me just put that in the calculator, that's going to give us a total of 137. So here I've got 137 plus angle F is equal to 180 degrees. Now, if I subtract 137 from both sides, okay, then I get that angle F is equal to 180 minus 137 gives us a total of 43 degrees. So this angle down here is 43 degrees. Therefore, that's the same thing here, okay? So angle C is 43 degrees, all right? So if we know that all of these angles are going to add up to 180, and that 81.2 is congruent to angle D, angle C is congruent to angle F, then what we conclude is that angle B is going to be also 55.8, okay? And I'm not going to go through the math there, but what that tells me is that all my angles from one triangle are congruent to the corresponding angles of the other triangle. Therefore, triangle ABC is similar to triangle DEF. Okay, now over here, all right, let's take a look. These are not similar triangles, okay? And let's look at a non-example. Okay, what we know is that angle G is 45.6, and so is angle J. It's also 45.6. We don't know what angle H is here, but and we don't know what angle L is, but I know that angle I is 86, and here this is 55.4. So let's figure out what angle L is, and we'll go from there, all right? And we'll see if we get 86. So here's what I know. Angle J plus angle K plus angle L, if I add all those angles up, I'm going to get 180 degrees. Angle J is 45.6. Angle K is 55.4. And we don't know what angle L is, all right? But we know that they all add up to 180. So 45.6 plus 55.4, 45.6 plus 55.4 is going to give us a total of 101. So I've got 101 plus angle L is equal to 180 degrees, all right? If I subtract 101 from both sides, all right, we get that angle L is equal to 180 minus 101, which is going to give us 79, okay? So angle L, all right, is equal to 79 degrees. Angle I is equal to 86, okay? So these are not congruent, all right? So not congruent. Therefore, these triangles are not similar, okay? And so all the angles from one triangle have to be congruent to the other in order for them to be similar. So let's apply that same thing to this, okay? Let's apply the fact that, here we've got these two different triangles, okay? We have triangle ABC and FEG, and we're just trying to figure out, okay, are these similar, all right? So here's what I know, is that angle B is 93.5, okay? And so I see that that's the same thing as angle E here. So that's good, all right? So angle B is congruent to angle E, all right? The next thing I have is angle A over here, I don't know, but angle C is 22, all right? And that angle G is 64.5. So let's find angle F, and let's just see if it's 22 degrees. And so let's set this up. Let's do 93.5 plus 64.5. If I add those up to angle F, I should get 180 degrees. All right, so let's do some math and let's figure this out. So 93.5 plus 64.5. Add those up, I get 158. So 158 plus angle F is equal to 180 degrees. Subtract 158 from both sides, and we end up getting that angle F is equal to, so 180 minus 158 is equal to 22 degrees, okay? So angle F is 22 degrees, all right? So I've got that angle B is congruent to angle E. I've got that angle C is congruent to angle F. And what we can conclude then is that, you know, if I've got 22 and 93.5, like I do here and here, the other third angle has to be 64.5. So angle A is 64.5 degrees, and that's going to be congruent to angle G over here, okay? And so let's write all that out. So angle B is congruent to angle E. We've got that angle C is congruent to angle F, okay? And then we've got that angle A is congruent to angle G. All right, so from that, what you have is that triangle ABC is similar to triangle, all right, so if I start with angle A, that's angle G, E, F, because remember, ABC has to line up. When I make my similarity statement, this statement has to be the same from this triangle over here. So we have to think about corresponding angles and sides. So that's GEF, so angle GEF, okay? And that's it, all right? So we're good. All right, so then, all right, you know, the angle, if we talk more about these congruent angles, corresponding angles, what we can figure out is that we have the angle-angle criterion, okay? States that if two angles of one triangle are congruent to two angles of another triangle, then those are automatically similar, okay? And here's the reason why, because we've been talking about this, all right? So if I were to take this first triangle, okay, which is 49 degrees plus 90 degrees plus angle L, all right, add all these up, that's going to give me 180 degrees, okay? Now, if I take the same thing over here and I do angle Y, which is 49 degrees plus 90 degrees plus angle Z, then that's also going to give us 180 degrees. So essentially what you have here from one triangle to the next is you have the same equation. And what you can conclude is that angle L is going to be congruent to angle Z. So you don't have to really do any more math. It's just that if these two are going to be congruent, if this is congruent to this, we automatically know that the third angle is going to be congruent to the other and that those are going to be similar. So my similarity statement, I would say triangle JKL is similar to triangle YXZ, okay? And that's that. All right, and so the third angle theorem, and that's what we just did, is that the third angles must also be congruent, all right? And let's figure out what it is, all right? So if angle J plus angle K plus angle L is equal to 180, angle J is 49 degrees, angle K is 90 plus angle L equals 180. So 49 plus 90 is going to give us 139 degrees. So 139 degrees plus angle L equals 180. All right, if I subtract 139 from both sides, 180 minus 139, then that's going to give us a total that angle L is 41 degrees. All right, if you subtract 139 from both sides. All right, that same thing is going to happen over here, all right, because you have 49 plus 90 plus angle Z is going to equal 180 degrees. All right, this is 139 plus angle z. You have the same equation. All right, if I subtract 139 from both sides, then I get that angle z is also equal to 41. All right, so these angles are congruent. Angle L is congruent to angle Z. All right. So a lot of theorems and stuff like that, but use these to answer some questions. So let me know if you have any questions. You guys are doing great, and you're on, my friend. See you later. Bye.